Is it now okay, Nandini? Hope it should be fine now. Yeah, thank you. Um, all right, so I thought I should seek the help of the packet tracer once again today to learn further. So what have we learned till yesterday? Let's have a quick recap. We have started learning about what is a computer network, and we also have understood what is a protocol. All right, to start with. Then we looked at the nuts and bolts view, which included all the edge devices, the core devices, the access networks, and so on. Under the access networks, we have spoken about the DSL, probably fiber to the home, coaxial line, the terrestrial satellite signals, and so on, right? So then we moved towards talking about the guided and unguided media. We have explored the various physical cables and the wireless media which are available. And we also went through the concepts of circuit switching and packet switching. We also understood the difference between the circuit switching and packet switching. And we were also very clear what's exactly happening in circuit switching and packet switching, how the packets are switched from one place to another place, and so on. Now it's the time for us to understand a concept called delay. Okay, delay and loss, throughput, and so on. Instead of directly jumping into explaining to you what a delay is, it's very easy. I can just draw a router having two devices and explain to you what is the meaning of delay. Probably you will start cursing me because you may not get it the way exactly you're supposed to understand. Okay, that's the reason I thought I should set up the stage with the support of the packet tracer today. All right, so I hope my screen is visible, so I'm going to go about. By the meantime, I also assume that you all have downloaded the specific version of packet tracer in your device, preferably the desktop or laptop device, and you have started using it. If you haven't done it, please uh, proceed in downloading and start using it. It is designed for you, for your uh, knowledge, to improve your skill set. All right, so we have understood the basic things. On the previous class, I have explained to you how two different devices can be connected with each other through no directly. Now, I thought we'll go a little further, right? And why can't we connect the systems using an intermediate device? Okay, that makes sense when you talk about the computer networks. Okay, for that matter, as usual, I'm going to take two end devices. Okay, I take one PC here. Let me increase the size of the screen. Okay, this should be visible. This should have better visibility than the previous one. And I go for another PC here. All right. So there are two computers I have connected. I'm sorry, I have just placed on the screen. All right. And I also said I'm going to use an intermediate device. Which could be the intermediate device? Probably I go for a switch to start with. Okay. Right. So probably a switch to start with, and I go for PT switch. Right. So you can take this PT switch and I keep here. All right. So this is the device I'm going to use to connect two N devices. So this is PC0, this is PC1. Let the name be as it is, and this is switch 0. All right. So I'm going to connect PC0 with switch 0 and PC1 to switch 0. In other words, switch is going to be connected with, no, between these two devices. In other words, I'm going to connect two machines to a switch. Probably that makes better sense, right? So how am I going to connect the cables? We know what kind of cable is to be used, but for the time being I also do not know what kind of cable is to be used because I'm learning along with you. So why can't we use the help of automatically choose connection type? Because in the previous class we understood we had connected two personal computers, right? And we used the automatically choose connection type, and it said we had to go for the crossover cable. Do you remember? It was a dotted line cable. All right, so when you connect two devices in the same layer, of same device, you would normally go for the crossover cable. Now I'm going to connect a personal computer with the switch. So I do not know whether the crossover cable is going to help me, or it may be straight through cable. I do not know. So in order to avoid the confusion, to start with, I go for automatically choose connection type, and I connect these two devices. Yes, as I expected, it goes for a straight through cable. It is not using a crossover cable. Okay. If it is to be a crossover cable, it must have been in the dotted line. Okay. It should have been in this format, as you could see on the screen. But it has used this straight through cable. Can we check whether that works? Yes, we can check by connecting the switch 0 with PC1. So I choose the copper straight through cable and I click on the switch. It asks me which port you want to connect. Okay, you are having fast ethernet 1 2 3 4 5 and the console cable. Now I do not know what kind of cable I should use, because I'm sure I'm not supposed to use the console cable for the time being. The reason is console cable is helping me in configuring the device. Okay, they are not designed for the data communication. In case I have bought the new switch today and I have to configure the switch, then I should use this console port to connect. All right. But now I'm supposed to use the other ports than the console port. Okay. If there is only one other port, it is easy. But on the screen, I could see 5 different ports, at least 2 different types of ports just by looking at the icon. One is a full yellow color. The other one is probably there are 2 dots kind of. Now I do not know which kind of connector or the interface I should connect. Okay, so I simply press escape. I do not know. So what should I do now? Let me go to the PC, because it is a PC which is an end device. Generally, the end device will have a limited number of ports compared to the intermediate devices. Okay, probably I click here. It says RS232 USB 0 USB 1. I'm not going to use the USB ports for connection. Okay, RS232 is something new I haven't heard about. Now probably I would go for fast Ethernet, because a similar icon I have seen in this switch also. All right, this yellow color. So I click this fast Ethernet and I click here. Now it tells me where do you want to connect. Now this should give me a hint, because I have connected with fast Ethernet 0, which is of yellow color, similar to, yeah, somewhere close to yellow color shape, yellow color, and shape is almost in the rectangular, maybe related, close to square. I could see a similar interface here. There are 3 such interface having the same identity. Okay, the color is also similar, the shape is also similar. So I click one of them. Thankfully it works. Right, now this is the way when you are confused, probably if you are not uh, uh, having adequate experience or exposure into using this packet tracer or networking, this is the way you should start learning. Okay, this is called self learning. Now this should work, I believe, because when I connected using the automatically choose connection type between these two devices also, I was seeing one amber color light. Where do you remember? I do not know how many of you noticed. Yes, it was showing amber color here, and eventually it became green. Here also you could see it was amber color, now it becomes green. Now please recall, when you were in the hostel rooms, as I said in the previous class, you were having the layer 2 switches placed in the rack, probably above your head level, somewhere in the corner of your the corridor, right, where you can see these switches blinking in green color in majority of the time. By mistake, okay, suddenly there is a power failure. All right, when the power goes off, you can see the switch is also shut down. And if it is not in the UPS, under the UPS connection, this is also going to be shut down. All right, so you will see blank because no lights would be glowing. Once the power comes up, once the power is up, you can see the lights would be blinking in amber color. All right, so I do not know whether you have noticed. You had time to notice. That's another story. All right, so that will become amber color, and slowly, eventually, suddenly that will become green, maybe in 30 seconds or 1 minute, depends on the switch type and how quick they converge. What's happening exactly when it was in amber color? What is the indication we are getting when it is green color? Well, when the switch is powered on, it goes for power on self test. Being a computer engineer, we all know when a computer is getting ready, okay, once it is the power is given, it goes for post power on self test, and then it loads the operating system, into the RAM, and then things are happening. Okay, the program counter starts running, and all these things are happening. The similar way, switches are also specialized computers. All right, so they also need some time to boot up. Even your mobile device, okay, all the smart devices take sometimes even 30 seconds or at least 15 seconds once the power is on. All right, very similar to that, it takes some time. During when the light is indicated using the amber color, no data transmission can happen except the control signals transmission among them. Okay, so that's a different story. All right, so this is how we are supposed to connect. Now we have connected two devices. Yes, now we know what is to be done next. We could see that it is showing in green color, uh, indicating that the physical layer is working fine. They are connected using the correct cable. What am I supposed to do next? Yes, you are right, we are going to give the IP address to this machine. So I click PC0. All right, I go to desktop and I click IP configuration button, and I give the IP address. So for the time being, I give very well known IP address 192.168.1.1. You may be wondering why it is always 192.168.1.1. Do you like the most? Not like that, but there is the reason why I'm using this specific IP. Please wait. Let me explain to you in a later class. All right. So I have given 192.168.1.1. To be clear, it is 192.168.1.1. And the subnet mask is filled in automatically. Don't bother now. I close it and I go to this mission. I do the similar one. Go to desktop tab, then open the IP configuration application, and I give 192.168.1.2. Okay, because the machines are supposed to have unique IP, I give 1.1 there. I'm giving 192.168.1.2 here. And once I press the tab, the subnet mask is filled in automatically, and I'm going to leave it as it is. All right, so I close it. Now I think I have completed the configuration. Let's check it. Okay, I go to this PC, I go to the command prompt, and you all have completed one of your laboratory exercises, which talks about the basic command prompt, the network commands. The very famous one is your ping command, IP config, interface config, and so on. So I use the ping command with the target network 192.168.1.1. I'm sorry, 1.2 I should say. And as soon as I give 1.2, yes, it works. This indicates that I'm able to reach that mission. That's okay. All right. Why can't we see this in the simulation mode? All right. So for that, I go to the simulation mode. Let me make it a little bigger. Okay. And I click show all or none. I go to edit filters and I click ICMP. Right. So now again, I'm interested to see only the ICMP packets, none other. And I do the same what I have done earlier. Probably I'll do it from this mission. I go to PC1. Let me keep it aside. Okay, command prompt, right? And I give ping command 192.168. Am I typing it lightly? Yes, 192.168.1.1, and I press enter. As soon as I press enter, you could see one ICMP packet is getting ready. All right, now so far this is just a similar one of what we have done in the previous class using packet tracer. Hereafter, I'm going to shift the gear probably by one. Right. So I could see a packet is getting ready, and I do not know what kind of packet. And I go to the simulation panel, and I am clear. Now it is a ICMP packet. It is Internet Control Messaging Protocol. You will learn about this in the network layer, right? And I click it to open. It shows a lot of inbound and outbound and other things. But what I'm interested is layer 3. Look at the layer 3 content, not this, the out layer 3 content. It says IP header source IP. Okay, source IP is 192.168.1.2. Is that right? Yes, that's right, because that's the IP of this mission. What about the destination IP? 192.168.1.1. So this is the destination IP. Now I am looking at this packet at the network layer. Okay, what is the network layer, sir? No, excuse me, you can remember that word for the time being. I'm looking at the packet at the network layer, which is the layer 3 from bottom. Source IP, I'm convinced it is 1.2. This is the machine which is sending the message. So source IP, there is a from address. Okay, from address is 192.168.1.12 here, and the receiver, the destination IP here is 192.168.1.1. What's the big deal? Fine. There is a deal on that. All right. Now, what happens? I close it. I'm not going to look at the outbound details because this may confuse you now. But this is what we have seen: source IP and destination IP. But don't bother. Just leave it now. I close it and I permit this to go one step. Now this packet has moved. All right. Now it comes to this switch. Okay. In this switch, I open this packet. Now you can look at this switch. Switches are not looking at the layer 3 data. Did you notice? I probably keep it here. If I could open the previous packet, oh, I could not open it simultaneously. Am I able to open it simultaneously? No, I'm not able to open it simultaneously. Yeah, I opened this packet because it was captured at the end device. I could see the layer 3 information. All right, so I'm closing it, but I'm opening the second packet. I'm not able to looking at the layer 3 information. Okay, this gives a clue to you that switches are looking at till the layer 2. Okay, sir, what is this layer 2, layer 3? No, please remember them for the time being. Okay, we can understand it very clearly probably in the subsequent classes. Okay, they don't look at the layer 3 data. Okay, they are not bothered about the IP address at all. Okay, but they are bothered about some address called Ethernet address. In other words, that is called MAC address. All right, that's okay. Why should you talk about all these things, sir? Because you said you are going to talk about delay and loss. Yes, I'm coming to the point. Yeah, now once the packet comes here, now the switch, unfortunately in this demonstration, the switch is connected, only two devices are connected. All right, now in case, okay, I have connected a laptop as well here. I'm not going to do that. In case I have connected a laptop like this, now the switch has to decide whether the packet has to be forwarded here or here. I hope you are getting what I'm trying to tell you, right? Now, when there were only two machines, okay, source and destination, one source, one destination, work is very simple. Whatever I'm sending will receive. It's very similar to the pipeline. Okay, take a pipe, water pipe. You send the water from one side, it's going to come on the other side. There is no branches. All right. But on the other hand, when you look at when you have more than one device is connected to the source or more than two devices are connected to the device, now the switch has to decide where the packet has to be forwarded. All right, I'm not going to use that device. So what I do, I go to delete. Where is delete? Here it is, delete, and I delete this device. Do you want to delete laptop 0? Yes sir, thank you. I'm not going to use it now. Okay, now I'm back with only these two devices. Okay, because I have added a new device, the earlier configuration was over. I delete this. What I'm going to do, I'm going to send a message once again. So the same thing, we are back to square one. This is where we were when we are talking. Now, do you understand that when you send a packet from the source to the destination, when it is getting processed at the switch, it takes little time. Why is it taking time? Listen, packet comes, the packet has to be opened, all right, and then you have to find out what is the destination MAC address, and then where the destination MAC address is found, the corresponding link has to be identified, and then the packet has to be put in that line. Okay, one of you have unmuted. Have you got any question to raise? All right, I think there is no question. I go back. Right. So now this device switch has to decide where the packet has to be forwarded if there are two, another two devices are connected. All right. This is called delay. The same kind of delay is happening at the route, out the switches, at the routers, at the hub, everywhere. All right. So that is constituting the concept called delay. All right. And when the delay is increasing, you will experience loss. Okay. That's where I'm slowly getting it. Let's finish what's happening here. So I allow this packet to go forward. We know nothing is going to be seen on the screen, right? And I still permit it to go. Nothing would be seen on the screen. I still say yes. Now you can see the first messages received as we have seen in the earlier one. Okay. Is that all about, sir? You have to speak today? No, no, no. This is called a unicast communication. What is that unicast? Uni means generally one, okay, single. All right. So what is unicast? When you are sending a message to one person, for instance, suppose I am talking to Amit here in the call. Okay, I'm addressing to Amit. All right. Now it is one-to-one communication. I am talking something to Amit, and others are not going to take part in this communication. Even if they are taking part, that is in the promiscuous mode. It is stealing mode. All right. They are not going to take part. There is another one which is called a broadcast. What is a broadcast? When I'm communicating something, it goes to everyone. For example, there are some 65 plus are in the call, including me, probably 70 or maximum. So out of the 70, I'm sending a message to all of you. All right. For example, the message I'm sending is, please listen. We are going to talk about this concept on Wednesday. All right. Suppose that's the message which I'm going to pass to you. That is a broadcast. Okay. I'm sending to every one of you. Okay. The third one is called multicast. What's happening in the case of multicast? Suppose I have a message to be sent only to boys or only to girls. Okay. Now this talks about the subset of this class. Could you get that? Now this is multicast. One to many, not to one to one, not one to all, but one to many. More than one person could be, not necessarily everybody. Okay. Now forget about the multicasting concept. Now we'll look at the unicast and broadcast. All right. The demonstration which I have given to you so far is the unicast communication. PC1 talks to PC0 and PC0 talks to PC1. A simple one, right? Now I'm going to demonstrate to you what is happening in the case of multicast. I'm sorry, broadcast. So to demonstrate that, I need at least another two devices. So that will look really good. Okay, so let me go and take another PC and I seek the help of those PC here, and I connect them using the cable. I have connected them. There is an Easter egg in Packet Tracer. If it is in amber color for a long time, you just switch between real time and simulation. You can quickly see that becomes green. All right. There is no magic. That's how the Packet Tracer is designed. Don't bother. I'll go to PC2. Let me give an IP here. I'm not going to take much time because you know this 192, 168. I give 1.3. That doesn't conflict. And I go to PC3. Here I give IP 192, 168, 1.4. Work. All right. In Packet Tracer, you got a benefit or a facility to see what IP address have we assigned. Just hovering your mouse over there. It is 192.168.1.3, 192.168.1.1. This should be 1.2, 192.168.1.2. 191.614. Okay, let me tell you what could be the common mistakes people can make. Instead of 192.168, you may tend to type suddenly 198.162. Okay, you won't make it deliberately, but by mistake it can happen. You will never be able to ping the machines because the IP is wrong. All right, so be careful whether it is 192, 168, 11. The network address should be common. Okay. Now I'm going to send a unicast message again. What is this that you are sending unicast again and again? Yeah, let me explain that. So I go to this machine, I send a unicast message 192.168, 11. Okay, and I go to simulation mode for that and I press enter. Okay, I'm sorry. Ping 192.168, 11. I'm again sending a unicast message. There is a reason why I'm doing that. And I press the play button instead of step by step. Could you see when I sent a unicast message, it started from PC2 because it was a message addressed to PC0 and the packet was going only to PC0. PC3 and PC1 are totally unaware of such communication which is happening. Did you notice that? I delete it. Okay, I delete it. Now what am I going to do? I go to this machine and I give a ping command and I send a message like this. Let me see whether this works. Could not find host to 255 Please check the name and try again. Okay, I'll try this one. 68 155. That works. I think that works. Okay, I'm sending a ping message. I only press button once. I press once again. Did you notice something strange which is happening here? If you haven't noticed, I don't know, because I sent a broadcast message. Okay, broadcast message is 192.168.1.255 in this network. How can I find out the broadcast address, sir? I will teach you, sir. I'll tell you later. Now the packet comes from PC2 to switch. I could not see any difference, but probably can I do in the reverse way? Let me see whether that works. Can you have a closer look now? I'll make it little slower if you have missed it earlier. Could you see that the packet was going from switch 0 to all the machines? Now this is called a broadcast message. Same message is coming from PC2, which is sent across everyone except the sender. Okay, when I'm sending a message, I'm in fact sending to all of you. Uh, the to address does not include me because I'm the sender. All right. Now, if you again closely watch, now these people are having some points here, which means they are preparing the response packet. Don't bother. I give next button. Could you see this packet comes? We'll see what happens next. That packet goes back. I got the response from him. Okay. And next person responds. And his response also is received. The other person's response is also on the way. You got the response. All right. So this is what happening in the case of broadcast message. All right. So hope you have understood. All right. Now I have got another 15 minutes. If you permit me, I can probably demonstrate you the difference between switch and hub. Okay. Because probably after that, we are not going to talk about the hub at all. All right. So let me pause for a while here. I go back to the screen. So is there anyone who got any question to raise? Shall I proceed? Vigneshwar, shall I proceed, Vigneshwar? Mr. Vigneshwar?
Yes, sir.
All right. So have you understood whatever I have spoken so far?
Yes, sir.
Thank you, Vignesh. Thanks, Jude, for the response. So I go back. Yes, Harshal, thanks for the response. Okay, so I go back to Packet Tracer screen once again, and I have demonstrated you the packet, the broadcast message, how it's functioning. I delete it, right? So now, mercilessly, I'm going to remove the switch, right? So what shall I do? You know how to delete the switch. I take this button, simple. I click it. It asks me, do you really want to do that? I close my eyes and say, yes, it's done. All right, the switch is gone. I'm going to place a hub in the place of switch. Where can I find hub? Go to network device. In the second row, you can see the third one. You can see hub. Okay, I take the packet tracer hub and I place a switch. Place the hub here. What else am I going to do? I'm going to use the connector to connect them. All right. Now you should have understood one basic difference between switch and hub. I do not know whether you noticed that. In the case of switch, when we were connecting, you were seeing that there was no green color light, I should say light, near the intermediate device, near the switch, right? It was initially amber color and suddenly it became green after some time. Okay, but here when you look at the hub, it is not the case. It immediately becomes green. Does it mean hub is very fast? I cannot comment on that. But one thing is sure, hub is not taking too much of load. Okay, it is very simple. It is very similar to short circuiting. Okay, you got a power plug connected to the socket, and you got a led light glowing somewhere, maybe in 10 meters distance, for instance. Suddenly your mom or father tells you, why can't you connect another bulb somewhere here? It is very dark in this room. What would you do? You go and buy probably a holder and the bulb, probably 2-3 meters of wire, and then you will cut it. What would you do? Take the original power supply which is going on, right? You will cut it, you will connect them. When you switch on, probably both the lights are going to glow. Isn't it? So the same thing is happening when you talk about the hub. Hub is just like a connector. All right. Very simple to take the cable and connect it. Okay, when the stream of water is going, you suddenly cut a channel and the water goes there also when you connect it. Simple. All right. That is what happening in the case of hub. That's the reason hub is relatively cheaper when you compare with switch. Sir, why should you have the switch, sir? Hub is very cheap. It is very simple to understand also. I'll tell you the basic difference with the hub. You should understand. Okay, don't only look at the money, but also the response these devices are going to give you when you are sending the message. All right. What am I going to do now? I do the same what I have done with the switch. I go to the PC. Okay. Let me not go to this PC. It is confusing. I'll go to PC3. Its IP is 192.168.1.4. I go to command prompt. Let me move to simulation mode before that. Okay. And I give ping 192.168 1 2. I think that will work. I press enter. Right. Now it's a time for you to watch carefully. I press this button once. I have pressed already. Okay, I press again. Okay, the packet goes to the hub. So far, I could not find any difference. Okay, if I'm blindfolded, I could not find any difference. I do not know whether it's a hub or switch. Now the hub is going to respond to this message. Have a closer look. Did you see that this packet is going everywhere? All right. If you are listening to the story which I have been telling for last 20 minutes, you should be really finding the difference. All right. You should understand what I'm trying to tell you. Okay. When I send a unicast message, all right, I'm sending a message from PC3 to PC1 with the target address of 192.168.1.2. All right. What the switch was doing, if you recall, switch was only forwarding the packet to that specific device, whereas the other two devices were unaware of this communication. Right. Now something strange is happening. I said hub is a device which is just a short circuiting device, just a repeating device. Whatever is sent from one direction, it's going to send it across all the other directions. Wherever you got the connection, it's going to forward. All right. Now this hub has forwarded the message to these three. But something good is also seen on the screen. What is that? See, computers and the devices or any of these smart devices are really genuine. Okay, they do not overhear or they do not open the letters addressed to others. All right. See, did you see? I sent a packet to PC1. I sent the target IP as 192.168.1.2. But this person's IP is 192.168.1.1. His IP is 192.168.1.3 or 4, something else. So they said, I will not going to receive. Is that true? Can we check that? I just click this packet and open at this header. Look at this. The destination MAC address does not match my MAC address. Okay. It is not my MAC address, sir, so I'm not going to process it. Interestingly, I am still going to make this packet travel further. They are not going to respond. PC0 and PC2 are not going to respond because the two address is not for them. They understand it has come by mistake. They simply drop the packet. All right. Now the PC1 has responded because it was addressed to him. Now he is supposed to respond back to the sender. All right. He has sent the packet, clear. And don't you think this hub is going to forward the packet to PC2, PC0, and PC3? Yes, what you guessed is right. The hub is going to do the same thing. It's going to forward the packet to PC0, PC2, and PC3. Again, PC2 and PC3 are little worried. Why this guy is forwarding the packet? Anyway, it is not addressed to me. Let me drop the packet. All right, the packet is dropped. Our communication is happening. So if you look at this in the real-time mode, you can't understand all this internal behavior of these devices. Okay, all you would see is that you have received the response. That's all. All right. Now I'll show you Do you understand the difference between the hub and the switch? Why switches are to be used? Still not convinced? I'll give you another example, another work. Okay, we sent a broadcast message, right? So shall we send a broadcast message? The same ping command. I'm going to send a broadcast message. All right. What was happening in the case of switch? The packet was sent. It was received by all the three. All the three were responding, and you got the response from everyone. Did you notice here? From one, you got the response. From two, you got the response. From four, you got the response. Everywhere, you got the response. Now I minimize this, and I permit this to go. No, sir, I could not notice any difference. It's okay. It's okay. You need not notice the difference. I'll tell it again to go. Now you could see it is received by all the three because it is a broadcast message. All the three have received. In the unicast message, do you remember? Two of them dropped the packet. They said it is not addressed to me. Now it is a broadcast message, so they have received it gently and they are preparing the response. Is it going to happen safe? Okay, why this ARP? Okay, let the ARP happen, no problem. Mm, all right, so okay, ARP has come in big in middle. I'll send the message once again. I say Control C. I send it once again. Why this ARP come in? All right. So I say go. It has gone. Let me make the speed little increase the speed. I say go. It has gone. I say go again. Okay, forget about the ARP. I send it again. What happens to this ICMP? I'll probably put the play button. Okay. Let this happen continuously. We'll see how long it happens. Okay. It can go a little faster. How many messages have been sent? I haven't counted. Shall we look at the response on the screen? It says request timed out. All right. I sent a broadcast message, right? In the when I was using the switch, I did not get request timed out. Did you notice? That's the reason I have opened the same screen. You have got the response on 1.1, 1.2, 1.4. You got two messages and then I stopped it. So it says request timed out. Okay. Now I have come here. See, I have used the hub in the place of switch and I sent the same broadcast message. You have not got any response because there is a phenomena called collision. Where you seeing the ARP packets were under fire, there were some fire happening. Okay, that indicates the collision of the packets, which means the packets are colliding each other. There is no proper response. It is very similar to more than 10 people or more than 4 people talking to each other simultaneously, which is not going to help anyone to understand what other person is talking to you. Okay, that's the reason you got the request timed out. So now do you still say hub is also a good device? For me, hub is okay when you don't bother about the packet loss. Okay, when you don't bother about the delay in the communication, you go for hub. It's cheaper. Just buy it and fix it. But when you really bother about the communication, the quality of the communication, the quality of service, you better go for the switch, though it is costlier than hub. All right. Now, what have I derived to you today? Okay, it was my attempt to explain to you the basic characteristics of the hub and the switch. In fact, I decided to include the router as well, but I'm running out of time. I got only 2 more minutes to go, so I may not be able to finish it. Now, you should clearly understand that the intermediate devices are taking time to process it. That is called processing time. That constitute a concept or component called delay. Okay, when you are sending a message from one place to another place, source to the destination, because of the processing which is happening at the intermediate device, there is a delay. It could be in microseconds or milliseconds or seconds and minutes. That's different. The magnitude might be different, but there is a delay involved. Okay, that's what I am trying to derive today. I hope you have enjoyed this session. In fact, I prepared another packet tracer version. Let me see whether I can show you. I don't want to save this. I had it in the desktop. Okay. Yeah, this is what in fact I wanted to use today, but probably I will reserve it for the next class. Probably the next Wednesday, we will look at the delays loss in details, and also we'll start learning about the various layers of the OSA reference model. Okay, so I stop sharing and I stop recording.